Okay, so artificial intelligence for product managers, and I'll go right into it. So before we start about artificial intelligence, this is one of my favorite topics. Like, let's discuss how did this artificial intelligence came about? What is human intelligence and what is artificial intelligence? So just a reminder to all of us, what makes a human intelligent? If you think about it, what really sets us apart from computers or animals, we as in humans, is that human beings are deemed intelligent. We have the capacity to problem solve, to learn, to sense, to reason with each other. We can have perception, we have the techniques to manipulate object, we have decision making skills, and we can recognize speech, and we can you know, do things using all of these abilities, which really makes a human intelligent. So, keeping that in mind, what is artificial intelligence? So then it becomes artificial intelligence is nothing but having a desire to have your computers do the same, what humans can do. So the ability of computer systems to perform tasks that normally requires human intelligence is really called artificial intelligence. So how can computers do what humans can do? And that is really artificial intelligence. For example, humans can drive cars. Can computers can drive cars? That's where we are going towards. Now we have driverless cars now. So that's all, driverless cars are all based on AI. So that's really what, in a nutshell, in an English, artificial intelligence is all about. Now there is this famous quote I want to remind everybody and myself. By far the greatest danger of artificial intelligence is that people conclude too early that they understand it. And what it really means is nobody has understood AI really well. What can it do, what it cannot do, and how does computer really become intelligent? How do they make decision? Many times people would think, oh, I know it all, but AI is really one of that space that it is very dangerous to think that we know it all. So then let's start with the history of AI. This becomes really important because artificial intelligence has actually been around for last 50 years or more than 50 years. There was a Turing test, which was created by Alan Turing. He was a computer scientist who proposed a test for machine intelligence. And what this test said is, if a machine could trick a human into thinking that it was a human being who responded to their questions and not a computer, then it was supposed to pass the test. And the machine was considered intelligent. And this was back in 1950. I'm pretty sure none of us were even born then. So at that time also, the whole idea of that machines can be intelligent and can respond in a way that it seems like a human being was thought about. So it's that long ago that artificial intelligence was thought about. And about 1955, artificial intelligence term was coined by the computer scientist James McCarthy. And then nothing really happened until 1980, when there was some investment made by some big companies, and machine learning saw resurgence, and the first autonomous vehicle actually appeared in the market. But then again, that funding did not really show too much real value through AI. And it was not until 1990 or even the beginning of 2000 that when deep learning and cloud computing started to come up, that artificial intelligence really started to thrive and start making big noise in the market. So it has been around, funding has been into it, been going into it for quite some decades, but it's only now that it is becoming more real and more relevant. So then one would think, why is artificial intelligence so hot now? And these three concepts are really important. And if you pick up even one of these concepts, you can build a career out of it. And these three trends or concepts really are data availability for AI, Trend two is improved AI algorithms and deep neural networks and machine learning. And trend three is really cheap, accessible compute power. This is where the cloud computing and everything comes into play. So I'll spend a few minutes to take you through each one of these trends. And you would think, why are these trends important? These trends are important because this is really the foundation of artificial intelligence. While some may say the number two trend, AI algorithms is what artificial intelligence is all about. Yes, that's how artificial intelligence becomes real. But without data and without compute power, artificial intelligence will not be able to see the light of the day. So let's get into it one by one. Trend one. So I'm pretty sure all of you have heard about big data. And big data has really enabled us to draw insights from a lot of data. An opportunity to find insights from different types of data with speed and with trust and at scale has really made AI real. So today, if you think about it, there is more data that is generated than ever before. And every time you click or you swipe, you are really creating data, and that data is used to make decisions about our future. And not only that, if you have read any articles around how much data is being created, a study was done by IBM which indicates that data is being doubled every year. And you would not even imagine, but 90% of the data that we have today has been created in the last 4 to 5 years. And it is this data that has enabled AI to break through so strongly. And in this sense, AI is really building off of the big data trends. So let's take the four elements of big data and see how big data is helping AI being so real. So there are four V's. The V is velocity, volume, veracity, and variety. These are concepts of big data. These are the four V's that come together, which really helps artificial intelligence become real. First is just the volume. So here I have said 40 zettabytes of data will be created by 2020, and it has increased about 300 times since 2005. And it is really technologies such as big data that has helped us manage this amount of data. If the big data technology wasn't there, we couldn't even manage the amount of data that we have today. And if we cannot manage this amount of data, then you don't have the data that will give you the insights needed for AI. Then the velocity. By velocity, what we really mean is analysis of streaming data in real time. We can get decisions in real time through big data. What that means is, take a moment to think, just compare this with the legacy data infrastructure that we have had in the last decade or in the previous decades, where we had to wait 24 hours for data even to be ported to data warehouse from the database tables. And then you would draw some insights, and then the insights and the analysis and the reports will be delivered after days. So you have already missed the opportunity to make decisions in real time. Now, big data has made these insights available to us in near real time, where in real time you can make decisions. And then the third concept really here is variety. And by the way, if I had to pick one of my most important, or not important, one of my favorite ones, it's the variety of data that we have today and the big data technology that helps us manage that variety of data. Once again, if you compare the data that used to be in a database, relational database tables, row and column, there was the structured data, one row, one column. Now, through this, now it is no longer just one type of data. We have structured data and unstructured data. Think about this data and you all will relate to it very easily. We have photos and videos and audio recordings, email messages, documents, books, presentations, and then tweets, your sensor data, your time series data, the data that you leave on Facebook, on Pinterest, on Instagram. All of this data, all of this heterogeneous input can now participate in decision making. Big data has the ability to take all these different kinds of data, analyze it, and make some prediction. For example, I'll give you a very simple example of Facebook. When you go on Facebook and you do something, or you even go on search, Google search, and you type something, in real time, if you go on Facebook, you will see an ad based on what you were just searching. So all of this data is being available in real time, which was the velocity making real time decision. And then on Facebook, when you tagged a friend, immediately there was a photo and Facebook was able to say, okay, I can make a decision on who this face could belong to. So there is a photo and image recognition going in. And in the weather data, all the sensor data, what is happening outside your home, whether it is snowing, not snowing, all of that information is constantly being collected, and you get information on your phones and on your screens in real time inside. So the ability to be able to handle this different kind of data has really made AI so powerful. And finally, the uncertainty of data. So when you have all of this data, data is sometimes good, sometimes bad, and big data has the ability to really cut through that noise and present to you the best data possible. Now, the second trend is the improved AI algorithms and availability. So it is the readily available machine learning, deep learning algorithms which has made AI so real today. And for example, the availability of open source algorithm, the neural network, parallel processing, which has now made it easier to develop AI applications. And a huge thanks to companies like Google, Amazon, Facebook, who have given us access to all of these open source libraries, some of it what you see on the screen, through which you can build your popular use cases. And what I'm showing you on the screen here is APIs or libraries or algorithms that is made available publicly through some of these tech giants or in the open source community. So why is it important? Why is it? It is important because now the developers and engineers or even R&D scientists who are trying to build AI applications no longer have to invest their time building some basic algorithms. They can use these open source or readily available algorithms and build their business applications using AI. So let's take an example of prediction, like the number 2, where Amazon forecast and Google predict. So Amazon, Google, and a lot of open source community algorithms are there for a prediction, where you can use this prediction API and give your input, call this prediction API, which is readily available, and you can get an output. Same with classification APIs. Classification APIs are very important concepts in AI, where you can take a classification API readily available and you can classify it, whether it like whether it is an anomaly or it is not an anomaly. For example, you can you can take an image, call the classification API, and you can ask, okay, what is in this image? Is it a number? Is it a photo, or whatever it is? So some of these basic algorithms have already been made available through these companies. And we will not have the time to go into each one of these, but if you had to take the time and pick one of these concepts and do more investigation on what these APIs could do, or even if you want to get your hands dirty, you can go to Google AutoML site or even Amazon Playground and even try it out. Like I tried out a lot of, these pattern recognition APIs or even an image recognition API. I used it myself using the image recognition API, which Amazon, Google, Microsoft, all of these companies have for free. You can put an image and give a lot of images and train your data, and they will be able to predict what this image is all about. Or you can give an image and they will be able to tell you, okay, what is in this image? Is there a car? Is there a road? Is there a traffic light? Some of these basic functionality, which your data scientist, your in-house data scientist can take months to develop, is already developed out there. So the concept here is some of the basic building blocks of AI is already made available through these companies. So now, as a programmer, as a data scientist in a business, you ride on top of these APIs and write your application as a wrapper on top of these APIs. And that's why it is becoming so successful, because now you do not have to go into the fundamentals of, you don't have to write the fundamental libraries. It's all readily available. And then finally, the compute power. This is again a very important trend. It is the access to super powerful computing at a reasonable cost, which has made AI so real. For example, some of you may also have heard about GPUs and accelerators, FPGA, ASICs. All of these accelerators are adding speed to your hardware and data center servers, which provide you high-speed computing. And it is important to understand that this trend is not just that the level of computing power available has risen exponentially, but also that the cost of computing power has simultaneously decreased. As a result, not only is the power of the computing that is available today is massively higher than it was in the past, but the cost has come down just as fast. For example, in the past, when AI was hyped, the cost structure just did not work for large scale adoption and impact. So if you go back in the history that I was talking about, in 1980s, it was just very expensive to run some of those AI workloads at the cost of the infrastructure that was back then. Now we have reached a critical point where the availability of computing power and its costs are both now in the range that makes AI a completely feasible activity for most business. And for example, just a few years ago, even if the computing power was available, the cost was just very impractical. And actually, I was seeing this demo at a recent trade show, and what they showed is a suggested workload that took months to process just 10 years ago was down to just hours 5 years ago, and is now down to just under a minute. And that is the speed of processing power, which is available now at a cost which is very affordable. So AI trends, so the three trends: the data that is available in petabytes, the algorithms that are written to support our applications, and the speed of computing power that we need at a reduced cost is what is really making AI so real now. So all these three things have to come together before you can really see your businesses succeed in artificial intelligence. Now, I will just pause here and give you just my viewpoint, why this was so important for a product manager to know. You may be even thinking, okay, tell me more about artificial intelligence, or gets into the deep technical knowledge about it. So here, as a product manager, I want you to know, when you are making decisions about what should our company be able to do using AI, the first thing you need to know is, what is the problem that you are trying to solve? So this is the screen here. What is the problem you're trying to solve? And is that problem can readily be solved using one of the algorithms available in the market? Because otherwise, if you are going to build everything from scratch, the cost of doing it may not be beneficial. And as a product manager, your main job at work becomes solve customer problem at the best return of investment, because it's not research and development where you can throw in millions of dollars without any real customer problems that were solved. So that's why these three concepts become important, that you need to see Do you have data available? Once you know what problem to solve, does it have the libraries available in the market to solve it? And many times, even if it's not available, you have a good data scientist, they can build it in-house using some open source code. Then do you have the data available? Then do you have, especially if you're starting out, like, do you have the compute power? Your company has the compute power, and will they be able to invest if compute is necessary to process that large amount of data that is necessary? And will it still remain a good return of investment? That's why knowing these three trends were so important. Now, before I close this first phase of my discussion and get more technical, I want to have you all think about this thing: computer versus humans and programming versus learning. So what is it that computers do well and what is it that humans do well? If you focus your attention on the left side, computers can carry really complex arithmetic expressions easily. If you give your computer to multiply those two numbers, which I can't even read, they will multiply it like what? As quickly as your head multiplies 3 into 4. But, and how does computer do that? Computers have been programmed to calculate. We have given the computers the rules, the multiplication tables, and the rules on how to multiply A into B. So computers have been programmed to calculate. But if the same computer, if you upload an image and you ask a computer, is this a cat or a dog? How are you going to program the computer to make a judgment whether it is a cat or a dog? That is what humans do well. Computers cannot recognize a photo of a cat easily, but humans have learned to recognize whether it is a cat or a dog or a cup or a chair. And if I have recognized how to learn a cat, then you give me a cat that is sleeping, a cat which is walking, or even a shadow of a cat, I will look at it and will say, oh, this is a cat. That is what human intelligence is. We have learned there's just no one way to recognize a cat. Any form or shape you show me a cat, a human being will recognize it. So that is what is about learning. Our human brain over time has learned. Like when you were a baby, you were shown maybe a cat or you had a cat. And next time you had another cat, the baby will know that it's a cat. But the baby will over time also know if you give to her a dog that it's not a cat. That's how smart human brains are, because we are learning, we are not programming. And that's where that's what artificial intelligence is all about. Computers have to learn to detect an object in a photo. This learning is called machine learning. So that's the really just the fundamental difference. Like when people talk about machine learning, what is the concept from a product management you need to know? It is that the machines have to learn. And now think about it, double clicking on learning. Did the learning happen the first time that you were shown something? No. You took time to learn. You had to process more data. You had to spend more time. And it is exactly the same concept for computers as well. So for computers also, you tell the computer the first time, then you have to continuously train the machines. You have to give more data, more information, and they learn over time. And that is really the concept of machine learning. Okay, now we get into the real meat of it. I'll do a time check. Okay, I'm not that, I think I'm okay. Okay, so yeah. Machine learning. So what I was just telling you, machine learning, right? So when we say machine learning, the first thing that came to my mind 5 years ago, okay, what is machine learning, or why does machine need to know? The machine, why does machine need to learn? Machine needs to learn so that machine can also make a detection about whether it's a cat or a dog. whether there was an anomaly or not, whether I can make decisions in real time, whether I can process things in real time, just like a human brain. So what is a basic machine learning framework? Just give me a minute. I need to drink just a little water. Okay. So a basic machine learning framework. Machine learning systems learn how to combine inputs to produce useful predictions on never before seen data. These are four sentences that I slowly uh, presented to you on the screen because there are four different concepts here. The systems have to learn based on the data that we give to the machine to make predictions on the data in when the model has been pushed in the live site. So on never before seen data. So in real time, when you have pushed your models into production, the machine will need to predict. So let's actually I will take you through an example. Taking a real world machine learning example, and I will go over some key terms that are used in ML. And I will use the example of categorizing if a particular email is spam or not, and see which machine learning terminologies are applied to this spam detection example. So, and all of you are using emails, and many times you would have seen that your spam emails have been pushed to the spam folders. What really you see there is a machine learning model working on your emails. So in order for the computer to categorize if a particular email is spam or not, we need to build models, train it, and then use it for prediction. So this is where we will go over some terminologies. So when we are training these models, we are providing them with labels. In this case, the labels that we will provide will be whether an email is a spam or not. And bear with me for a few minutes, everything will come together. I know it could become a little complicated, but these concepts are pretty simple and it will all come together. So you would have, and some of these terminologies are, you can call keywords in the industry, labels. When somebody says machine learning and labels, what it means is you are telling your machine what it needs to predict. In this case, the machine needs to predict whether an email is spam or not. So the label will be spam or not spam. Then the second concept is features. Features are input variables that describe our data. So now how will a machine decide whether an email is spam or not? It is based on the features. So here the features can be who is sending me the email, who is the email going to, what is on the subject line, what are the words in the email. All of these things become features. And who decides what are these features? These are the domain experts, the business analysts who know their domains very well or who knows their business application well, gets to decide what are these features based on which you will decide whether your email was a spam or not. In this case, let's say I send an email to Menka. So in my case, or in many cases, Menka's email is very valid. Or from is from Mamta. I'll say, okay, from, check for from. If Mamta is a valid email address, so it's a not spam email. But if from is a very suspicious email, right? Something like you just received $1,000.com, you know it sounds suspicious. So that is what we mean by features. In the subject words, if you say sometimes, oh, you win a lottery, click here and we'll give you a reward. So a lot of those things are treated as spam, even if it may be a valid marketing message, but many times a lot of these could be deemed as spam. So those are really features. Then the second concept is example. Example is nothing but example data. And here we will have a subset of data which we call the training data, and that training data is labeled. So example is a particular instance of data, and labeled data, labeled example means we have a feature and we have a label. Feature means it has to, from, email, subject, word, and along with it, it will say spam or not spam. So the labeled data set is used for training. Then we will save some amount of data that we have as an unlabeled example, which will only have the features, but it doesn't have the label. That means the computer will have to predict on it. So when somebody says unlabeled examples, that means they are going to use that data to test, not really to train. Then the second part of the key terms is like models. So now we come to the model. A model defines the relationship between the features and the label. So model is the thing that is doing the predicting, something that we create through a process of learning from the data. So as I was telling you, even in our real world example, we need to continue to learn over time. And when we are learning over time, we are creating a mental model in our brains also. We will say, okay, a cat should look this like this and this. If we get a photo which has a four-legged creature, which has two goggle-eyed, maybe it's a cat. So those are your mental model, and it's the same concept that the computer is also training itself, trying to establish a relationship between feature and the model. But then the model has two phases. One is the training phase and the inference phase. The training phase is where we are continuously creating and learning on the data. And once we have trained our models, we will get a fully trained model which we will move into prediction. And that is called the called the inference or the prediction phase. In this phase, we move our fully trained models into production. And here the training and inference phase, you can simply think of training phase as a macro, as an Excel or a Visual Basic macro. It's not exactly that, but the concept, you can think about it. Or even as you are creating your, you're constantly training your model and trying to tune it so it is perfect, comes close to it, and once it is ready to be moved into production, you package it and you move it into production. So when you move it into production, that is the inference or the prediction phase. When you have applied your trained model into production, and that is where it will actually give you the real-time values. So just to kind of recap, what we are doing here is we will have like there are 4 or 5 things: labels, which tells you what you're predicting; features, which are used to predict predict the label, in this case, whether the email was spam or not spam. Then you have data, which some data you keep to train the model, other data is to test and predict the model. And then the model is a relationship between the features and the label. And then the model itself has 2 phases: training and prediction or inference. And here you say inference is the word we use for deep learning, whereas prediction is the word we use for machine learning. So now the different types of machine learning algorithm. So what you just went over is what are the different, what are the different terminologies and what are the different ways it gets generated. There is supervised learning, unsupervised learning, and reinforcement learning. These are the 3 main types of learning, and I'll just briefly touch upon it. So supervised learning, what the example that I just gave you about email being a spam or not is a supervised learning. And why is it a supervised learning? Because we told the machine, we gave the machine a labeled data set telling whether it is a spam or a not spam. So similarly, we can train a machine giving the machine thousands of images that says, these images are for cat, these images are for dog, this is for John, Dave, and Peter, and the machine will learn it. So then when in prediction you will send an image of a dog, the machine will able to say, yeah, this is a dog. Now there is another kind of learning, which is unsupervised learning. So unsupervised learning, we don't have this thing about being able to give every data a label. For example, if you see, I know it's pretty small, the image, the sample, there are lots of potatoes. I think this is potatoes. There are red potato, black potato, yellow, and brown potato. Now, how do you train your machine to know which one is a black potato and yellow potato and red potato? You don't. Where this kind of algorithm comes in, if you see clustering, you give tons and tons of these kind of images, and you tell your machine that the similar kind of objects have to be clustered together. So that's what it has done. In this case, it will not say this is a black potato or a yellow potato, but what it will do is it will separate those potatoes in a cluster, that these are all red potatoes and yellow potatoes and brown potatoes. And then there is reinforcement learning, which is learned by trial and error. In this case, the computer learns to detect the next best action. And this is really used in robotics, where let's say a robot is going towards a wall and it hits a wall, then there will be a negative feedback score, and it learns that, oh, I shouldn't hit a wall, and they learn it, and then they will say, okay, before going to the wall, just stop. So that's kind of a reinforcement learning. So here I've just give you a picture from a Data Robo website. What are the different machine learning life cycle phases? But I'll skip through that and get into some other, I will go over that again in a few slides. One other concept about machine learning is, when you talk about machine learning, a lot of time machine learning experts have to build, not, sorry, a lot of time, machine learning experts have to build machine learning models. But what they really spend most of their time is cleaning and organizing data. 60% of their time is just spent in cleaning and organizing data. And if you see, only like about 20% of the time is spent in creating the model and refining the algorithms. So organizing and cleaning the data becomes a huge part of developing machine learning algorithms. So once again, as product managers, when you are trying to create these business cases or applications for AI, always keep in mind what amount of data you have and how much data preparation and organizing would it require. And you don't have to do that yourself. You meet with your data engineers, with your data science team, and try to understand what shape and form your data is all about. And that's another extremely important concept. Again, some of these concepts, I will just breeze through it because itself, these concepts could take me an hour to go into it. But the data pre-processing for machine learning. So it's not just simple. When I talked about that 60 to 80% of the time is spent just really cleaning up the data, this is what we are doing. We collect all the data from different sources. Data can be geographically dispersed. It can be in different places, different servers. You collect that data. Then you have to do data cleaning. Data cleaning would just mean you cannot take all the data and give it to the computer if you see there are values missing, there are information which is not correct. So you have to remove all that data. If there are missing values, maybe you have to actually manually enter it. Data transformation, normalizing. A very simple example is if you're collecting data from, let's say, England, the distance will come in miles. If you collect data from India, the distance will come in kilometers. So you have to normalize all that data. And then data reduction. When you have collected all of this data, sometimes a lot of data is not also useful. Sometimes you have to reduce that data. you have to reduce that data so that there is no data bias. Sometimes you'll say, okay, I got this data only 5 rows from a certain country that may be heavily biased towards something. So let me remove that data, and domain experts will know. So all of these 3 or 4 steps can take like 80%. Sorry, I'm not going to animate it. I was going to show you that wheel can take about 60 to 80% of your time. And when you finally get your well-formed data, that is when you are really ready to build your machine learning model. So most of the time is actually just spent preparing your data based on the use case or the problem that you're trying to solve. So this data set then becomes the data for machine learning. So then the real machine learning process starts. Now go back to the example that I was just going over, the email example, whether it is spam or not. How does it done? Like technically, that was the concept. So here I say require feature engineering. So in the training development environment, the training data, let's say you collect 5,000 email samples, and in that email sample, you have a features that said to, from, subject line, and those were the features, and the label was spam, not spam, spam, not spam. That is all that the label says. So one of the feature set would look like, you got a lottery. If you see this in the subject line, that means it's a spam. So that's the feature engineering. So somebody has to sit and actually hard code that feature and label it. And then you train your model constantly to create a machine learning algorithm or a model, and the constant training happens. And then when a learned model is ready, and how do you know when a learned model is ready? So when your model is close to being able to accurately detect whether it's a spam or a not spam, then you test it out through a test data. And when you are kind of sure that yes, it may be all right, you push that model into production. And then once your model is pushed into production, the green boxes are nothing but it shows how the data, then in real time, when an email arrives, the model will look at the features, it will look at the subject, to, from, and decide in real time whether it is a spam or a not spam. So then what is deep learning? And I know now I'm a little over time, but I'm almost to the end also. Deep learning. So what I have shown here is deep learning as compared to machine learning for a quick grasp of how it is done. So in deep learning, which is one of the most popular way of machine learning today, is something where you do not require feature engineering. So if you don't require feature engineering, how does the machine learn? So how the machine learn is, we give our computer lots and lots of data. And what we will do is, we will give our computer, let's say, 10,000 images, again, keeping the example of cat and dog, 10,000 examples of a cat standing, a sleeping, cat drinking milk, cat chasing another cat, all different forms of cats, 10,000 images, and we will label cats. So we'll tell a computer that these 10,000 pictures is all cat. So what it will do is, the computer itself will train itself that, okay, and create a model on its own using different layers. And I'll get into the layering part in a little bit. The computer learns on its own that, okay, this is all image of a cat, and creates a model on its own. That is all about deep learning in a nutshell. Like if I had to dumb it down, the ability for the computer to learn on its own, given huge amount of data, and it creates its own model. So there is no feature engineering phase. And feature engineering is a very expensive activity because you require a domain expert, and you require somebody to go and label that create those features. But in this case, it's a very powerful technique where computer learn on its own. But there is two drawbacks. When the computer creates its own models and algorithms, There is no way for the human being or the data scientist to know how did the computer generate this model. And then it becomes an issue because in many times legally compliance or regulations asks us to be able to reproduce why a certain decision was taken. And when that happens, we are not able to use deep learning. So in many instances, deep learning is not a good idea, but in many instances, deep learning is a brilliant idea where we do not need to have to go back and trace why certain decision was taken. And in this case, deep learning becomes really powerful, where the computers are able to train in itself. And in this case, where does deep learning becomes very useful? Like the example that I just gave you, or trying to detect an audio signal and lots of audio signals, and is it able to detect voice from music? These kind of things, if you give tons and tons of audio files to the training data, the computer is able to learn on its own and creates its own algorithm. So there is something about neural networks which ties into deep learning. Now, how does computer learn then if we are not giving the features and not telling it explicitly, right? We did in the email example. That's where the neural network comes in. Just taking a pause here. Yeah. So how does neural network, so the concept of neural network is really inspired by our human brains. The artificial neural networks mimics how a brain works. And what you see here is an artificial neural network on the right, an actual neuron of your brain. So let's get into understanding how a neural network works. And by the way, this is where the bulk of our machine learning, deep learning data scientists spend their time. So what you see here is the simplest neural network with only one hidden layer. So what this neural network is the foundation of deep learning. And what this neural network has is a neuron, a synapse, and the neurons are these circles where what, and these neurons are interconnected by what is called the synapse. And by the way, if you study the human brains, it's all coming from the human brain's terminology. And then an artificial neural networks has three layers: an input layer, hidden layer, and the output layer. The input layer is where you input all the data. And this is where you will tell your computer, this is the input layer where the computer will get, let's say, all the images for the cat. Now, the hidden layer is what is responsible for learning different parts of the features. And these hidden layer, while you only see one layer, there can be thousands and thousands of hidden layers. And this is where the deep part of the neural network comes in. So deep learning, the deep learning comes from this hidden layer. Typically, there is generally not a one layer. There'll be at least several layers, and it can get to dozens or hundreds of layers depending upon the complexity of the prediction. And then we have the output layer, which has like one node to many relationship. And this is where the results are stored. Once again, I know these concepts are a little difficult to comprehend if you're learning it for the first time, but the concept, once you understand it, becomes very simple. How does the machine then learn is really based, and if you're not telling the machine that this is a cat and this is a dog, this is the concept. And I am going to take you through this example here. And by the way, this is one of my final slides, and then I can open it up for question and answer. So how does the neural network works? So once again, I'm going back to the training phase that I was talking about, the email and deep learning and everything. In the training phase, tens and thousands of images are presented to the neural network. These images are labeled and the network learns how to classify them. So what I'm trying to tell you here is on the input layer, we will give tens and thousands of images of a cat in different, well, let me take this example where I'm showing a dog. We will give our neural network, the input layer, tons of images, and all of those images will be in a different state of a dog. And using those different hidden layers, the machine will try to come up with a neural network, which is the output layer, that, okay, this is a neural network to determine that it is a dog or a not. And that neural network, the final neural network, is then pushed into production. So then so that the first, this one was the training phase. Then the input phase and unlabeled. So once your network is trained and you send an unlabeled image to this newly trained network, the input layer will take that image of that dog, and then the first layer will detect, the neuron will respond to simple shapes. The first layer is just responsible for finding the shape. It will just gather some shapes from this image. From this shape, then the second goes to the second layer, and then neurons respond to more complex structures and different set of features. Once they are able to determine the shape, they will try to find, was there an ear? Was there an eye? So the second layer gets into determining other features. And these two layers, here again, for the sake of an example, I only have one box outlined there. There'll be multiple layers that kind of determines what this image is all about. And you get to the top layer where the image is able to extract highly complex concepts, and it will be able to match to different animals. So then finally, when it will be able to build the shape of an animal, then in this stage, the machine has now learned. Typically, a machine has already learned, like whether it's a cat or a wolf or a dog or a cow, not a cat, but similar kind of animal. And now if you see in the top layer, it has maybe a pig, a wolf, a horse, and even a dog. And then finally, it gives you a prediction that the network predicts by 90% certainty that this may be a dog, and 10% probability that this may be a wolf. So this is how really the deep learning and network works. Now, one important thing I have not covered, but I have been talking about it, prediction. The thing to know about machine learning and AI and deep learning is a concept about prediction and not a decision. A decision is more definitive, that yes or a no. Yes, it's a dog, or no, it's not a dog. That's what computer programming does. In machine learning, what computer does is just gives you a prediction saying with certain amount of trust and probability, the machine learning algorithm is saying that 90% chance that it's a dog. Now it is up to the business analyst, programmer, data scientist, end user application. They determine what action to take. So AI by itself is not a definite science. It predicts, it gives you a probability on which you build your case. And that is one of the very important things that we need to know. So that was about deep learning, machine learning. And once again, these concepts are extremely technical, but from a product management point of view, if you understand these terminologies and what it means, I think that is kind of enough for getting started. Now, if I had a second level of session where I went a little bit deeper into it, then I could explain you certain concepts a little bit more, where what you need to know more, what kind of algorithms goes with which kind of application. Knowing that level of understanding is also important for a little advanced product manager in AI. Then finally, I would like to end with what are some everyday use cases of AI. Social media, voice assistant, maps, Uber, Lyft, banking. They are all these everyday experiences that you go through, and AI is embedded in it. And once again, I'm not going to go into each one of them. It's self-explanatory, and I'll open it up for a question and answer. What I also have here is some extra slides uh, for you to just have a idea about, and some suggested reading. And the first step, the 7 steps of machine learning, is a great follow-up from my session today. Okay, let me see how many questions we have. You know, in the interest of time, if you don't mind, let me cover like 60 seconds for some of these. And by the way, I will already tell you some of these answers I may not know tip of my hat, but I will follow up with Menka. How do we define the MVP for AI initiatives? My favorite questions. My favorite question. Actually, defining an MVP for AI initiative is extremely important. And for AI, the industry recommends start with an MVP. And there are many ways to go about it, but I will say start with your lowest hanging fruit where you find the data. Once again, if you go back and see, let's say, okay, let me give you an example. Actually, I'm going to do a time check so that I don't go overboard on one example. Let's say I'm an e-commerce retail product manager, and I want to build a AI experience, show me more like this. If somebody uploads an image on my website and I say, okay, there are more shoes that looks like this. This is an AI use case. And as a product manager, I really want to build it. And by the way, I'm giving you a real world example. When I wanted to build that experience for my website, the first thing I had to do was go back and check, do I have the data? I had the data where I could make a comparison of similar shoes. But the second thing you have to check is how difficult will it be to create an algorithm? Can you see if there is something readily available in the market to create a quick use case? Or, by the way, I know I've been saying use what is available in the market. It's extremely important for MVP. But now that you're talking about real world, if you have a data scientist, ask him, how quickly can you develop an algorithm? Can you use something which is readily available, or do you have to do it uh, uh, all over again or by scratch? So data is very important. And once you have the data, the second thing you need to know only comes from real world. Even if you have that data, does your data scientist have access to that data? In my case, the example that I just gave you, I couldn't build an experience out of it because the data about different product images was in a different set of database, which was not available through an API to my data scientist. So in a nutshell, how do we define the MVP? Find out if you have the data available, find if that data is available to your data scientist. This is the technical part. The most important part, and it has nothing to do with AI, I would strongly again tell you, the product managers, try to understand what are the top pressing business problems you have. From them, try to go through, can that business problem be solved using AI? So I would ask you even before, so the finding what MVP to be built should still start there. What business problem you have to solve? In my case, when I was recommending the image one, I wanted to try, my business problem was the search was not returning good results and hence users were dropping. So see the problems that your business have, can it be solved using AI? And if it can be solved using AI, you have 5 problems, then you see which one you have the data for. So that's how you start. And how you define that MVP, do it a pilot within your own context. Anyway, I will stop there. Is Mamta offering any course from transitioning to PM roles in AI platform? I'll skip that one.
Okay.
I could do that, but I'm
That's
like,
my
yeah, I'm
favorite
not a
question.
faculty. Yeah. 80% of AI initiative fail to deliver business value. To overcome that, how do we tie business KPIs to model metrics? Oh, this is, you know what I'm sharing. So the most important thing is 80% of AI initiative fail to deliver business value because you have picked the wrong problem. So this is an excellent question. So Vijay, there was a slide which I skipped, which was for this, and I'm going to, let me see if I can still go back there. Okay, let me escape. So the reason they fail is the project objective was not defined. What happens is, and this I'll only give you 30-second answer because otherwise I wouldn't be able to cover, and tying it into the KPI and metrics is all covered here. So what happens is 80% of them are failing because they all started by engineers and technologists because they wanted to deliver something using technology, and it becomes technology in search of a problem. The initiative fails because they don't show value because they have already used, they were good experiments, but you were not able to scale. You were not able to scale for two reasons. Your algorithms, one, your data couldn't scale, couldn't be deployed on the on in production sites. And remember the compute power. By the time you asked your DevOps teams to scale, that you wanted massive compute power, they said, oh, we are not ready, we cannot buy more hardware, we cannot, we don't have the compute power you need. So there are tons and tons of reasons why it fails, and many times it goes back to those three trends. But most importantly, you specify the business problem. And the stat that you're giving, I know about those stats. And just that stat, if I dig deep, you have never picked up the specify the business problem, acquire the right subject expertise. But when you come here, uh, no. I was going to see where it was about setting up the right success metrics. Maybe I don't have it here in this one then. In the project objective, oh yeah, so this thing, define unit of analysis and prediction target. It seems very technical, but this is where you define your metrics. What is it that you're targeting? What are you trying to predict? So the reason they fail is really because the the problem that you were trying to pick were not the right problem. So you have to define the right problem metrics, right problem statement, and model metrics. And Menka, if you send me some of these questions,
Yes.
I can send some articles, and I'm not promising attendees that I'll send it tomorrow,
I
but in the
understand.
next week or 2 weeks, I'll send you relatively accurate answers via articles. For
Definitely.
regulated industry like healthcare, how to overcome the challenges of model interpretable of FDA approval. So yeah, this is where I was saying, so many times for healthcare and all, deep learning can and cannot be used. But the quick answer to this is if you Google the concept model management. Model management has become a uh, um, big industry business where there are companies that will keep a version of the model based on every version that was deployed into production. So the quick FDA approval answer is model management, where model management comes with three things: governance, traceability, and model versioning. So if you just say model management, those are three things, and I can send some articles. So Vijay, this has been tackled, and model management industry for healthcare and financial services is becoming really popular now for the reason that they have to trace what was the decision-making criteria. How do a product manager gauge when to stop viewing through a AI lens and think of a product as a whole? How much value can one draw to the product through AI? And I'll tell you, it may come as a surprise to a lot of you why this. As a product manager, it is extremely important to know AI, and AI can shape a lot of our products. But still, as a product manager, your fundamental responsibility is to serve your customer need and serve your business problem. Now, pick a problem that your customer has to solve, and then see what technology has to be applied. Now, that said, you absolutely need to know AI, because for all you know, the business problem that your business is suffering with till date can only be solved using AI. And the reason it has not been solved up to now in the industry is because AI was not there. So AI may be the answer, but don't make AI the answer and then search for a problem. The reason I'm saying it, if you had that lens where you find the problem and then see which technology to apply, you'll be an extremely successful product manager. And then if you know AI inside out, how it can help solve your business problems, then you will know that, oh, AI can help me solve the business problem. So just 10 seconds, Menka, I'll take more to
Definitely.
complete this thought process. So what I'm saying is, let's say your business problem has, I want to improve the search. I want to improve the search findability of my site, which means if the customer said shoes on Flipkart, Flipkart is able to return all the shoes and doesn't return, pots and pans. If that is the customer problem you have, then you say, okay, yes, I need to index my database, this and that. But if you are now a very well versed in AI, you will say, hey, I know AI can solve this problem, because AI can now tell, okay, shoes have to look like this. Using image recognition or pattern recognition, my search can become better. Then you go back and tell your data scientist or your technologist, let's use AI to solve my business problem of findability. So knowing AI is absolutely a must have. So again, start with what are your top business problems, and then quickly see, is AI, and just Google, can AI solve findability problem? Can AI solve my medical FDA, like some, I don't know, I'm not from the healthcare industry, but clinical trial, how can AI solve my clinical trial problem? Start with the problem, not with AI.